Hello students, welcome to GK's Maths classes, your ultimate CBSE class 12th mathematics guide. Together, we will turn this class 12th mathematics from challenge to your strength. That is our motto of this channel. Okay. Now today we are going to start with chapter 3 of class 12th syllabus, that is matrices. In this video, we will be talking about introduction to matrix. I will call this as part 1 of the video. We are going to do only introduction today, and in the subsequent videos we are going to solve problems. Okay, and I also request you to subscribe to my channel and also to press the bell icon. Okay, let us begin. Now, what is a matrix? A matrix is nothing but a representation. I have a huge collection of data. When I have huge collection of data, how do I represent the data? There must be a way to represent the data. One of the way to represent a data is talked by matrices. Now, what is this matrix? You arrange the data. I call these data as nothing but elements. Okay, you arrange these elements in rows and columns. So it gets a form of a rectangle. So rectangular arrangement of elements in rows and columns is called a matrix. Okay, rectangular arrangement of elements in rows and columns is called a matrix. I'll give some examples. So you look at the example here. I'll take some examples. One example is, say for example, I have A, B, C, D, E and F. You see, rectangular arrangement of elements A, B, C, D, E, F, which is in the shape of a rectangle. Now clearly the horizontal entries are called rows, and I will change the color to red. The vertical entries are called column. Horizontal entries are rows and vertical entries are called column. Then we go to the next definition called order of a matrix. The order of a matrix is defined as number of rows by number of columns. This into, you have to read it as by number of rows by number of columns. So how many rows are there? There are 2 rows. And how many columns are there? There are 3 columns. So the order is say 2 by 3. The order of this matrix is 2 by 3. Number of rows by number of columns. We'll take some more examples. Now let me write -2, 3, alpha, beta, A, C. This is also a rectangular form. So tell me, how many rows are there? The horizontal entries are rows and vertical entries are column. So what is the order of this matrix? The order of this matrix will be 3 by 2. Number of rows by number of columns. There are totally 3 rows and 2 columns. We'll take one more example. Look at this. This is A, B, C, E, F, I, -1, 0, 3. All these are elements. Now, horizontal entries are called rows and vertical entries are called column. So, how many rows and how many columns are there? It has 3 rows and 3 columns. Therefore, the order of this matrix is 3 by 3. You know, every square is a rectangle, but all rectangles are not square. So even though it is in square form, I will say rectangular arrangement of elements in rows and column, because square can also be treated as a rectangle. Let's take one more example. A, B, C and say example F. Horizontal entries are rows and the vertical entries are column. So what is the order of this matrix? The order of this matrix is 2 by 2. Let's take one more example. Say A 1 0. So how many rows are there? It has one row. How many columns are there? It has three columns. So the order of this matrix is, say, 1 by 3. So let's take one last example. I have covered almost all types of matrix in this. 1 2 3. How many rows are there? It has two rows. How many columns are there? It has one column. So what's the order of this matrix? 3 by 1. So rectangular arrangement of elements in rows and columns is called a matrix, and we have also discussed about how do you define the order of a matrix. Okay. Now what is the general notation of a matrix? How do I represent a matrix in general? Okay. Suppose I want to talk about a matrix of order, say 2 by 3. I will generally write it as A equal to, in square bracket, Aij, where the first suffix I stands for row. So the maximum value of I is 2 and minimum value is 1. So the number of rows is 2, and the second suffix j, here the second suffix is j, the maximum value is 3. So the order of this matrix is 2 by 3. So Aij, where Aij is called the element. Aij is an element. Okay. So the first suffix, I am not saying I stands for row and j stands for column. I am saying the first suffix, here the first suffix happens to be I. So I stands for row and second suffix j stands for column. Now how do I write this? I can write it as A1 1. When I is 1, j is 1. Then A1 2, A1 3. You see, first row, first column element. First row, second column element. First row, third column element. And there are only 3 columns. So I go to the next row. Second row, first column element. Second row, second column element. Second row, third column element. So A11 means first row, first column element. A12 means first row, second column element. A13 means first row, third column element. So this is a general way of writing a matrix. And also I want you to remember, a matrix can be put enclosed by a square bracket or a curved bracket. Okay, you can enclose it by a square bracket or a curved bracket. Do not use parallel lines. Do not use this because this comes under determinant. We'll discuss that later. So I hope this part is clear to you. Rectangular arrangement of elements in rows and columns is called a matrix, and the order of a matrix is number of rows by number of columns. And I have given you various examples of matrix, and I have also talked to you about what is a row and what is a column, and we have talked about the order of a matrix and how you represent a matrix in general. Okay. Now let's move on to the next part. Now we are going to talk about different types of matrix. What are the various types of matrix? The first one, I've written the definition so that we can save time. First one is called row matrix. A matrix is called a row matrix if it has only one row. It can have any number of columns. So for example, already we have talked about it. So this is A, B, C. How many rows are there? It has only one row. And how many columns are there? It can have any number of columns. We don't care. So this is of order 1 by 3. We'll take one more example. Say 0, 5. What's the order of this matrix? Very good. 1. And how many columns are there? It has 2 columns. So order is 1 by 2. So this is a definition of a row matrix. A matrix is said to be a row matrix, okay, if the number of rows is 1. Okay. In your class also you can make it, you can understand it. When the students are sitting in rows and columns, you know the first row, okay, the horizontal, when you're facing the students, the horizontal arrangement, the first row, you call it first row because it has only one row and there are so many students sitting. Suppose if there are 10 students sitting, the order of that matrix is 1 by 10. First row is 1 by 10. Now, what is the column matrix? So if you have understood row matrix, then column matrix is very simple, because if the number of column in a matrix is only 1, if the number of column in a matrix is 1, it can have any number of rows, then it is called a column matrix. Now what is the example? A, B, C. Look at this. It has 3 rows and it has only 1 column. So what is the order? 3 by 1. Let's take one more example. 5, 2. It has 2 rows and it has only 1 column. So the order is 2 by 1. Always row first, then column when you are defining the order. You cannot write column first and row. It's a convention. Okay. So this is how you define row matrix and column matrix. Very simple definition. If the number of rows in a matrix is 1, it's row matrix. If the number of column in a matrix is 1, it's called column matrix. For row matrix, it can have any number of column. For column matrix, it can have any number of rows. It doesn't matter. But for row matrix, there should be only 1 row. And for column matrix, there should be only 1 column. Okay? Can I continue further? Now look at this. The next jump, the square matrix. What is a square matrix? A matrix is said to be a square matrix, obviously, if the number of rows is equal to number of columns. So for example, you have alpha, beta, gamma, 0, 1, 3, A, B, C. What is the order of this matrix? 3 by 3. Okay. Now, 2, 5, 1, 7. What's the order of this matrix? 2 by 2. Perfect, isn't it? So very, very simple definition. If the number of rows, I didn't say rows and columns are equal. If the number of rows is equal to number of columns, then it is said to be a square matrix. Okay. Now what is the speciality of a square matrix? In a square matrix, only for a square matrix, you have a diagonal. Well, this is the diagonal. I don't care for the other diagonal. I'm not interested in the other diagonal. I'm only interested in top left to right bottom. Top left to right bottom. Top left to right bottom. This diagonal is called, there are many names you can give. You can call it leading diagonal, or you can call it principal diagonal, or you can call it main diagonal. Any name you want, you can give. But only a square matrix will have diagonal. Just look at the rectangular matrix. A, B, C, D, E, F. This is not a square matrix and it will not have diagonal. Which matrix will have diagonal? Only a square matrix will have diagonal. Am I clear? Okay. Now that you've understood what is a square matrix is, our next job is to understand what is a diagonal matrix is. Now very clearly it's given, diagonal matrix is a square matrix. So you know how it's going to be. The number of rows is going to be equal to number of columns. Non-diagonal elements must be 0. All the non-diagonal elements must be 0. So these are the diagonal elements. For suppose if I take a 3 by 3 matrix, I call it A, B, C. The non-diagonal elements, these are non-diagonal elements. All the non-diagonal elements must be 0. Diagonal elements, all elements should not be 0. It should have at least one non-zero element in the main diagonal. It should have at least one non-zero element in the main diagonal. Now this can be in short written as diag. Diag means diagonal. A, B, C. That means diagonal element is A, B, C. How do I write this? A, 0, 0, 0, 0, 0, 0, 0, 0. Is it a diagonal matrix? Yes, of course it's a diagonal matrix because it has one non-zero element, A. If all the diagonal elements are 0, then you can't call it as a diagonal matrix. Okay. So how do I write this? Diag A 0, 0. Now how do I write this matrix? Diag, suppose for example AB. So when it says diag AB, that means diagonal element is only 2. If it is only 2, it has to be a 2 by 2 matrix. Am I right? So what is a diagonal matrix? A diagonal matrix is a square matrix which has at least one non-zero element in the main diagonal, whereas the non-diagonal elements, all the non-diagonal elements must be 0. All the non-diagonal elements must be 0. This is a very simple definition of a diagonal matrix, and there are some notations that you can have. Okay, so diagonal, so look at this. Diagonal element is ABC, whereas all other elements are 0. Now look at this. It has one non-zero element in the diagonal. All other elements are 0. Now look at this. It has non-diagonal element in the diagonals, whereas the other places it is all 0. So all non-diagonal elements must be 0, and it should have at least one. At least one, now one or more. It can have at least one non-zero element in the main diagonal. Okay. Now let's go to the next definition. Very important. It also came this year in the board exam. What is a scalar matrix? A scalar matrix is a diagonal matrix. You know what is a diagonal matrix now? A diagonal matrix is a square matrix. So it should be a square matrix. Okay? And since it is a diagonal matrix, all the non-diagonal elements must be 0. I have not filled the diagonal elements. If the diagonal elements are all same and non-zero, if the diagonal elements are all same, then you call it a scalar matrix. See, a scalar matrix is a diagonal matrix if the diagonal elements are all equal. A. Diagonal elements are all equal. It is a diagonal matrix, but it's a special name called scalar matrix. Because why? Because there must be some difference between diagonal matrix and scalar matrix. The diagonal matrix, what happens? In diagonal matrix, all the non-diagonal elements are 0, and you can have different elements in the diagonal. But if all the elements in the diagonal are equal, you can still call it diagonal matrix. It's more a common name, but specifically you get a name called scalar matrix. A scalar matrix is a diagonal matrix which has all elements same in the main diagonal and non-diagonal elements are 0. Okay. Now, very important definition. Very important definition. Unit matrix or identity matrix. Very clearly it says it is a scalar matrix. If it is a scalar matrix, it has to be a diagonal matrix. Correct? So I am putting all the non-diagonal elements as 0. If the diagonal elements, they have to be equal, not just equal, but all the elements must be 1. If all the elements are equal and if it is 1, you don't call it scalar matrix, but you call it unit matrix or identity matrix, and it is generally denoted as I, or some notations are there. You can even call it I3. When I say I3, it means a matrix of order 3 by 3. Okay. Now, you can also have a matrix like this, 1, 1, 0, 0. So what is the order of this matrix? It's 2 by 2. So how do I denote it? I2. Okay. So what is the speciality? Why this matrix is so important? In real numbers, your multiplicative identity 1, in real numbers, your multiplicative identity 1 is very special. If you multiply any number with 1 or 1 with any number, what do I get? I get back the number. Similarly, in matrix, you are going to study matrix multiplication later. If you take any matrix and multiply with I, or I with any matrix, you get back the matrix, provided multiplication is well defined. Remember, it is not possible to multiply any two matrices. We'll come to those things later in the next video. Right now, let us assume that AI is possible. If AI is possible and IA is possible, and if I is the identity element, then you'll get back the matrix A. So this is a very, very important property. You can keep a note of this. Any matrix multiplied with I or I multiplied with A will always give you A, provided of course the multiplication has to be well defined. Similarly, you have this wonderful resultant real number. If you multiply a matrix and its reciprocal, you get back 1. Similar idea is there in matrix. If you take a matrix A and multiply by its inverse, I call this inverse. You can right now, for the time being, understand it as 1 by A. Okay? Or you can take 1 by A. 1 by A is A inverse. You read it as A inverse. What will you get? In matrix, what is my 1? It is nothing but I. So these two results are very, very important for me. If you multiply any matrix with I or I with any matrix, you get back the same matrix. If A is multiplied with its inverse and A inverse is multiplied with A, when I say A inverse, it's like 1 by A, and there are a lot of conditions right now. And just for since I'm introducing unit matrix, I'm just saying this. A must be a square matrix if inverse has to exist. All that we'll discuss it later. But right now you understand, if I just like this result, we have a resultant matrix. What is the result? A multiplied with A inverse or A inverse multiplied with A will always give you an identity matrix. So something that is very, very important. So one identity matrix acts like number 1 in real numbers. Here identity matrix is like number 1 in set of all matrix. Okay. Next one. Very simple definition. When we talk about 1, we should talk about, when we talk about multiplicative identity, we should talk about additive identity. So something similar, okay, not exactly. Now what is zero matrix or null matrix? It can be of any order, I don't care, any order it can be, but it can be of any order, but all the elements must be 0. Now see this, 0, 0, 0, 0, 0, 0, 0. I have given you one example of a rectangular matrix and I have given you one example of a square matrix where all the entries, all the elements are 0. All the elements are 0. If all the elements are 0, you call it a zero matrix, otherwise called a null matrix. Now, equality. One of the biggest application of matrix is solving system of equation. You can solve system of linear equations or system of any equation using matrix. Matrix A and B. If I have two matrices, if I take a matrix A as say Aij and matrix B as say Bij. Now I want to make it clear. Here my suffix I stands for row and my suffix j stands for column. The first condition is order of both the matrix must be equal. That means suppose I is a order, it's I and this is j. What's order of this matrix? This is a matrix of order 3 by 2. So obviously B should also be of order 3 by 2. Both should be of same order. Now let me write this. 3 rows, 2 columns. So A11, A12. I can't go to A13 because my j's maximum value is only 2. Then A21, A22, A31, A32. So you can see clearly this is a 3 by 2 matrix. If you want A to be equal to B, B11, B12, B21, B22, B31, B32. And you can see clearly both the matrix are of same order. Both the matrix are of same order. And if you want the matrix to be equal, then the corresponding element should also be equal. See, A11 should be equal to B11. A12 should be equal to B12 and so on. Okay, that is in general you can say Aij should be equal to Bij. Aij equal to Bij. So these are some of the basics that you should know. Okay, so what did we do today? We talked about definition of matrix. We talked about order of matrix. Then we talked about what is a row matrix. Just recollect it. If the number of rows is 1, then you talked about what? Column matrix. That is, number of column is 1. It can have any number of rows. Then we talked about what? Square matrix. That is, if the number of rows is equal to number of columns. Then we also discussed about what? Scalar matrix. Diagonal matrix. Diagonal matrix is your diagonal element should have at least one non-zero element, and all other non-diagonal elements are 0. Then we also talked about what? Scalar matrix. Then I talked about unit matrix. Then we discussed zero matrix. And finally, we talked about equality of two matrix. Okay. So this is the introduction. With that, we will stop. Okay. With that, we will stop. We'll continue with the exercise problems and additional problems in the subsequent video. Please do not forget to subscribe to my channel and to press the bell icon. Thank you very much. Have a nice day. Bye-bye.